The full name is a little bit longer than most projects. In fact, I would have liked to see an acronym or something that we can, but anyway, if we're looking for something, I guess Hyper-I comes quite easily, but the full name is Optimizing Hyper-I, then an integrated solution for assessment of fertility and gender of pre-incubated eggs. So in terms of what we are seeking to accomplish, I think most of that is quite obvious, or we try to make it obvious in the title. So one is eggs, pre-incubated eggs, assessing the gender and the fertility of incubated eggs. And I can talk about a little bit on the background of that just shortly. But what we really want to do, what we really want to accomplish in the project is to design a system which we call Hyper-I. There are some recent discussions on whether we have another name for that, but at the point that the project was submitted and went forward, we were calling it Hyper-I. So to design our Hyper-I technology that would be able to scan eggs, pre-incubated eggs, and make a decision on the fertility of the eggs, whether it's fertile or not, as well as on the gender of the eggs, whether it is male or female. And then the system would then include the scanning hardware, camera, lighting, then also include the algorithm, the analysis of that, which will be embedded within the system, as well as actuators, mechanical or robotic or some other systems that would separate the eggs according to their fertility and according to the gender. So that could be an arm, a robotic arm that would pick up, that will receive information from the algorithm, information, the gender levels or the fertility levels, and then based on those levels, know the exact location of the eggs, and then to be able to sort the eggs according to fertility and gender. So basically that's what it is. So the eggs come in, they are scanned, information is sent to the algorithm does the analysis, sends it back to the system, the actuators that will separate it, and then away it goes. The decision is made which one goes into the incubator. And then the great thing about this is that the ones that do not go into the incubator can at that point be redirected and reused as ingredients in the food supply chain, or even in the as animal feed, whatever the case is. But the point is that it can be reused in the value chain, in the egg value chain. The poultry industry would account for about, I think, close to 8% of the total cash receipts, in Canada, farming operations in Canada. So it's significant. The poultry industry, or the Canadian poultry industry, is significant from an economic point of view. But then if you look at that and drill into that a little bit more, then you find that particularly in the hatcheries, that they are spending energy, they are spending incubation space just incubating eggs that would not hatch, right? So about 10% of all the eggs that are handled or that are set in Canada would be infertile. So right away there is 10% saving. And then you've got the 50% of all the eggs would be male that will eventually be destroyed. So right away, from an economic point of view, as the industry, would be saving at least 50% of the eggs that they will produce, which 50% can go back into some economic stream that would bring in some revenue to the industry. But then also, and this is also important, now, if they are able to retrieve the 50% plus that would normally go into the incubator, then there is a real opportunity for them to immediately increase the capacity, right? Because then, of course, instead of carrying 100%, then which eventually gets reduced to 50 or 45%, they are able to increase their production capacity by at least 50%, which I think is significant, because then they would be reducing energy cost, and then they would be at the same time having revenue stream come in because of what would normally go not into waste, but now that could be of value, reducing labor costs as well, and at the same time having efficiency, a significant increase in their production efficiency. And I was interested in exploring how I might expand the application of hyperspectral imaging. So we had a small project. There was a call at that time from PIC. I think they are still there. That's the Poultry Industry Canada. And they asked for ideas and proposals, and I submitted a proposal to them for using hyperspectral imaging to assess egg quality, and in particular also the fertility of eggs. So, and they funded it. It was a tiny seed funding that they provided, and we had, as you know, at McGill, we still have a poultry facility there. So I went over to our poultry facility. They were very, very supportive of that. And then we had this test done where we had some fertile eggs. They were artificially inseminated, and then the eggs were there, and then we had table eggs. So we did the study, and we were consistently getting 100%. So which means we were able to identify fertile eggs and separate fertile eggs from non-fertile eggs. So we were very excited about that. The social issues that we are trying to address would be to minimize or to eliminate or minimize this killing or destruction of day-old chicks that is going on right now, which has other consequences. And I'm trying not to be ahead of myself in terms of talking of the environmental and economic influences. But certainly the main thing is that there is a life destruction that the technology would immediately address. It took 3 years for us to get the patent approved. And then, of course, from then on to move on to building a commercial to scale up. We started with 300 eggs. We had to scale it up to 900 to 1,200 to a point where we are now at 10,000 eggs that we are scanning. And we are just getting ready to move it more towards 500,000 eggs. And that would be really the excited. So we're going to, in the new year, to have a 20,000 incubators that we were going to be able to bring in 20,000 eggs into the incubator and then test it so that, of course, we increase the scale sequentially. And then all the time checking whether the result remains consistent. So So there is some excitement for sure, and there is also some nervousness that I guess anyone who has developed the technology, so you are hoping that with scale that the results and the performance of the prediction remains. When we started to increase the speed and the scale of operation, we also found some other challenges to do with the light. It was very quickly, we were using QTH light, for instance. And then that's how, if you operate that for a long time, it generates a lot of heat. So we needed to switch over to LED to reduce that. And it turned out that just designing LED lights has been surprisingly for me very difficult. We've talked to 3 companies that manufacture LEDs. In fact, this morning I had a meeting with one company in Italy that manufacture LED, and just the technical challenge, just the technical complexity of designing an LED, particularly LEDs that will deliver illumination at the wave bands that we want, has not been as straightforward as I thought. I had no idea what it involved to design LEDs. But in any case, that's something that we are actively working on, to design a light source that would work on an industrial scale and can work consistently without having to either change after 1 hour or 2 hours of operation. It's made a huge difference for us. I think I'm going to say on a number of fronts, but I think CAAIN has given us a credibility with the egg farmers supporting, and because it was competitive. So I think it's always good when you go to a competition, you write a proposal and it's peer reviewed. You get that additional boost that, okay, fine, and there are people out there that appreciate what you're doing, and then it gives you, if you are running in a race, it gives you that additional energy to go on. But then more specifically, the actual cash infusion into the project, I think is definitely not trivial for us, and it does make a difference for us to be able to have the hot blood, the people in the room that are dedicated on this and are able to work on that on a full-time basis. We've been able, in the last 6 months or so, we've been able to hire, I think, 4 people. One in particular was a little bit difficult because we applied for a system engineer, photonics engineer, and it was quite hard to find, which is a different topic, but surprising, but a different topic. But the CAAIN project has allowed us to be able to get the right people within Canada, and bring them into the project and maintain them and be able to operate, keep the doors open. I think that has been really, really, really helpful.